Imagine Netflix decides to save bandwidth. Instead of checking whether you're still watching, that's a while loop, it cuts you off after exactly 4 episodes. It knows the full sequence up front. Episode 1, 2, 3, 4, done. That predetermined repetition is exactly what a for loop does in Python. Today we master for loops and the range function. First, let's see why for loops exist. Here's the standard while loop pattern for repeating code a fixed number of times. You initialize a counter, say n equals 0. You test a condition, n less than 4. Inside the loop, you do your work. Then you increment n by 1. 4 separate pieces spread across 4 lines. Here's the danger. Forget that increment line, and your loop runs forever. That's an infinite loop, one of the most common bugs beginners write. Even experienced programmers make this mistake when code gets complex. The for loop solves this by design. It collapses those 4 lines into just 2 and makes infinite loops from a forgotten increment impossible. Here's the for loop structure. The for keyword starts the statement. Next comes a variable name. You pick whatever makes sense. Then the in keyword, followed by a sequence of values. Finally, a colon to begin the indented block. The indented lines below form the loop body, the code that executes each iteration. Compare this to the while loop. No initialization line, no increment line. Python manages both automatically. Your variable name can be anything. Ni count episode. The in keyword is the mechanism that binds your variable to each successive value. Every time the loop body finishes, Python grabs the next value from the sequence and assigns it. 2 lines replace 4. Let's walk through the execution model. Python sees the for statement and examines the sequence. It assigns the variable the first value, then runs the entire indented block. When the block finishes, Python returns to the for line, assigns the next value, and runs the block again. This cycle continues until every value in the sequence has been used. After the last value's code completes, the loop ends and the Python moves to the first line after the indented block. The variable keeps its final value. It doesn't disappear. The whole process requires 0 manual bookkeeping from you. We need sequences of numbers to feed our for loops. The range function generates them. In its simplest form, range takes 1 argument, call it n. It produces integers starting at 0, counting up by 1, stopping before n. Range of 5 produces 0, 1, 2, 3, 4. 5 values, but 5 itself never appears. This is the most common mistake with range, expecting the stop value to be included. It never is. Range of 10 gives 0 through 9, 10 values, but 10 is excluded. A useful mental model, range of n gives exactly n values, starting from 0. Let's trace a complete example. The code for n in range of 5 print n. Range of 5 generates 0, 1, 2, 3, 4. First iteration, Python sets n to 0, print output 0. Second iteration, n is reassigned to 1, output 1. Third, n becomes 2, output 2. Fourth, n is 3, output 3. Fifth and final, n is 4, output 4. The sequence is exhausted and the loop terminates. 5 lines of output, 0 through 4 from 2 lines of code. Behind the scenes, Python handled every reassignment of n. It checked whether values remained. It stopped when the sequence ran out. The bookkeeping a while loop forces you to manage. The for loop did silently. And once more, range of 5 did not include 5. The last output was 4. Range accepts up to 3 arguments: start, stop, and step. Start is the first value in the sequence. Stop is the boundary. Always excluded. Same rule as the single argument form. Step controls the increment between consecutive values. When you call range with 1 argument, you're providing only stop. Start defaults to 0, step defaults to 1. With 2 arguments, Python interprets them as start and stop, with step still defaulting to 1. With all 3 arguments, you have full control over the sequence. This pattern mirrors string slicing, but range uses parentheses and commas instead of square brackets and colons, and it generates integers rather than extracting characters. One important detail, step can be negative, letting you count backward through a descending sequence. 5 examples, range of 4. Start defaults to 0, step to 1. Sequence 0, 1, 2, 3. Range 3, 5 starts at 3, stops before 5. Sequence 3, 4. Range 1, 4, 1 starts at 1, steps by 1, stops before 4. Sequence 1, 2, 3. Same as range 1, 4 since step defaults to 1 anyway. Range 1, 4, 2 starts at 1, steps by 2. 1 is included. 1 plus 2 is 3 included. 3 plus 2 is 5, but 5 is not less than the stop value 4, so it's excluded. Sequence 1, 3. Finally, range 4, 0, negative 1 starts at 4, decrements by 1, stops before 0. Sequence 4, 3, 2, 1. 0 is excluded, consistent with the rules that the stop value never appears. Now let's use these ranges in loops with operations. First, for j in range 1, 4, 2, print 2 times j. J takes values 1 and 3, 2 times 1 is 2. 2 times 3 is 6. The output, 2, then 6. Second, for I in range 4, 0, negative 1, print the $ repeated I times. When I equals 4, $4 appear. I becomes 3, $3, then 2, then 1. The loop builds a descending staircase of $signs, shrinking by 1 each line. The loop variable drives the computation and the range controls the sequence. 3 takeaways. For loops, assign the loop variable each value in a sequence automatically. No manual initialization or increment. Range of n produces integers from 0 up to but not including n. Range with start, stops, and step gives full control over where the sequence begins, ends, and how it moves. These two tools replace verbose counting patterns with clean, error-resistant code. To practice what you just learned, this course has free exercises and AI-graded feedback on ludium.ai. The link is in the description.